Here we're given a linear systems word problem that involves a mixture of oil and gasoline. Well, not quite a mixture, but we're buying two of them, and we want to know how much 1 liter costs. Okay, but what we're given is the cost of 4 liters and 50 liters, and 3 liters and 35 liters of oil and gasoline, respectively. So I'm going to again highlight the important information. So I know I'm looking for 4 liters of oil, 50 liters of gasoline. I know the total cost is $42.50. For 3 liters of oil and 35 liters of gasoline, I know the cost is $30.30. What I'm looking for is the cost of 1 liter of oil and 1 liter of gasoline. And as always, those will define my variables. So let me define X as the cost. So let X represent the cost of 1 liter of oil. And for Y, it's going to represent the cost of 1 liter of gasoline. So let's put this here, and instead of X, I'm going to have Y, and instead of oil, I'm going to have gas. I'll just say gas for short. And those are let statements. So we need to create two equations, and I'm going to use the information provided above. So the first piece of information is that I know the cost of 4 liters and 50 liters together is $42.50. In other words, if I were to multiply the number of liters I buy of oil times the price of oil per liter, and do the same thing with the gasoline, I'm going to end up with $42.50. Similarly, if I start off with 3 liters, so 3 liters of oil and 35 liters of gasoline, I'm going to end up with $30.30, because that's what the second piece of information gives me. And I want to find the cost of 1 liter of each. In other words, I want to solve for X and Y. And at this point, we know that we have to use a linear system method, either substitution or elimination, to solve. And in this case, I'm going to use elimination. And I'm going to eliminate, I think the easier of the two variables is probably the one involving X. So I want to get a common multiple in front of the X term. And it looks like with 3 and 4, that common multiple is 12. So what I'm going to do is multiply my first equation by 3, and my second equation will be multiplied by 4. My new equations, which I'll write just over here, are going to look like this. I will have 12x plus 150y equals $127.50. Similarly, for the second equation, I'll have 12x plus 140y equals $121.20. To eliminate now the x variable, notice that the 12x's match up. I want to subtract the equations. That way I eliminate the x, and I'm left with 10y, and that equals 6.3. Divide both sides by 10. Divide both sides by 10, 10, 10. This cancels, and I'm left with y is equal to 0.63. In other words, 63 cents for a liter of gas. And for the x value, well, I just take that and substitute it back into one of the original two equations. I'm going to choose this equation here to plug it into. So I'm going to replace y with 0.63, and I get 4x plus 50 times 0.63 is equal to 42.50. If I go ahead and solve, I end up with 4x equals 11. Again, I'm doing this multiplication together, bringing it to the other side. I'm going to divide both sides by 4. And this leaves me with $2.75. So x is 2.75. So to conclude, we can write our therefore statement. I can conclude, therefore, that gas is 0.63 dollars per liter, and oil is $2.75 per liter.